Welcome, and in this tutorial we're gonna be answering these two questions. So these two questions are based on limits, and now in this case they're telling us to show that the given limit does not exist. So if a limit does exist, what it would mean is that whatever path I am going to take, whatever line I am going to go along, the limit will still remain the same. But if the limit does not exist, which is the case which we're trying to prove, if it does not exist, it means that I can find a path or a line in which when I take the limit there, it will give me a different limit from another path that I am going to take. Then the limit there does not exist. So this here is gonna be quick, it's gonna be short. So what we are saying is, so for question one we have this limit, which is just the limit x comma y as we approach 0 comma 0. Then this is xy over what, x squared minus y squared. So we must show that the limit does not exist. So for this one I'm just going to go along the x-axis. So what do I know about this? So along the x-axis, it means what? My y is what? My y is 0. So I let my what? My y to be equal to what? To be equal to 0, because I'm going along that what? That x-axis. Then that would mean that my limit, because y is 0, it means that I just remain with what? With x. So of my function as I approach what? 0 now. So now I'm going to have that this is going to be, I have x there, so I have x and I have y. So my y is 0 because we are dealing with the x-axis here. So y is 0. Then I'm going to divide this. Then I have x squared minus the y squared, which is just 0 in this case. So I have that this is going to be, so x minus the 0 just gives me 0. So I have the limit as x approaches 0. The limit as x approaches 0 of what? Of 0. And this here is going to give me what? Give me 0. So for the first one, I have that the limit is what? Is 0. So now I try a different what? I try a different path and check if the limit is going to be the same. So I'm going to try the line. So I try the line y equal to what? To mx. So I try the line y equal to mx and see what this is going to be here. So of course I am presuming, as I said, that when we said saying let that be equal to 0, so meaning I have the limit as x approaches what? 0 is what we're saying here. Okay, and you see why, because here we've written this to say I've written y to be a function of what? Of x. So it means when I replace there my y, I'll only have this limit to be in form, or to be in terms of what? In terms of x. So in terms of x, and of course the constant what? The constant m. So where there is x, so I have x and y. So where there is y there, where there is y, I'm going to replace mx. So I replace mx, and then I have x squared minus, then where there is what? Where there is that y, I am going to have replacing the mx here as well. So I have x squared. So what does this mean? This means that the limit, so you see it's all in terms of x, so I can't have a y there. So I'm going to have, this is going to be x as we approach 0. Then on top, what do I get on top? So I'm going to have, that is m, then I have x what squared, then I have x squared, then when I square that there, I'm just going to have that this is going to be so that there's just going to be minus the m squared. So I have minus m squared and what? And x squared. So now you see the limit as x approaches 0 for this one, mx squared. So down there I have an x squared, that is a common factor. So I have x squared, then I'll remain with 1 minus m what? M squared. Notice that I can cancel out this m here, this x squared and that other x squared. Then I'll have that this here is just going to be equal to, so the limit as x approaches 0 of what? I'll have m over 1 minus x squared. I have m minus 1 over what? X squared. So now you see that this here has no x in it. So if I put, I have nowhere to even put. So meaning this is just going to give me what? To give me the same m over 1 minus x squared. But this here is different from what I found. This is not equal to 0. The m over 1 minus x squared is not equal to what? To 0. So this here shows that the limit what? The limit does not exist. So you can write this in words to say that since the paths we have taken are not equal, are not giving equal limits, it means that the limit does not exist. Okay, let's do the same for this question, for part B of the what of the question. So I erase this. So erasing this here, erasing that, erasing that. Okay, what do I get? So I have the limit. So now we're looking at the limit as what? As x comma y. This of approaches 0 comma 0, and then my function is just x over y then divided by x cubed then plus y what? Y cubed. I must show that the limit does not exist. So I go again. I'm going to go first again along the what? The x axis. So I go along the x axis, and this here means that I let my y be equal to what? To 0, because I'm going along the what? The x axis there. So then this makes my limit. So my limit is going to be as x approaches 0, then where there is y, I'm going to what? I am going to replace my 0. So 0 there, then I'll have that this will be x cubed, then plus what? 0 there. I cube the 0, still gives me 0. So then on top it will give me 0, then I'm dividing by 0, which just gives me 0. So I get the limit as x approaches 0 of what? Of 0. But this here is going to give me 0. So in the first case, I have found that my limit is actually what? 0. So I go through another line and see that am I going to still get the same limit here? So I'm going to go along the line that is y equal to what? To x. Y equal to what? To x. So for this one here, meaning I'm going to have the limit as, again, I am replacing, where there's y, I'm replacing x. So meaning my function will only be in terms of what? Or this limit will only be in terms of x. So there's no need for me to write that y there. So meaning I'll just write it in terms of what? X. So that will be y, x as I approach what? 0. Then where my x is, where my y is, I replace x. So I have x there, replace the y, which is x. Then I have x cubed. Then I replace there where there is what? Where there is y, I replace the x. So I just have this will be x cubed. So this then is just going to give me that the limit as x. So this is going to be the limit as x approaches 0. Then on top I have what? X squared. Then there I add the 2 because those are common, so I'll just get 2x cubed. Then I can divide this here because I have a common term of what? Of the x squared. So this is x as I approach 0. Then I divide this, I just get, I'll have 1 over what? Over 2x. So 1 over 2x. Okay, good. So this is gonna be now the limit as x approaches 0. I can factor out that half. So I have factored out the half, then I remain with 1 over what? 1 over x. Now I must analyze this. What is the limit as x approaches 0 of 1 over what? 1 over x. So if I look at the graph here, if I was to sketch this 1 over x, you see that I'm going to have something like this. It goes that way and it goes that way there. So this is y and that's the x here. So what is this going to mean for me? So for me, this means that when I am approaching, so you see that when I am approaching from the right, when I'm approaching it from the right here, so when I approach it from the right, what do I get? So when I approach from the right here, so when I approach 0 from the right, so in short I'm saying the limit as x approaches 0, that's from the right, so I indicate positive there. What am I going to be getting? So this function goes to what? To positive infinity. So this gives me what? Positive infinity there. That is of 1 over x if I approach it that side. If I approach it from the other side, that is the limit as x goes to negative here of 1 over x is just going to give me what? Negative infinity, because this here goes to the what? To the negative. So negative infinity. So you see now that as I'm approaching, the limits are actually different. So if the limits are different, it means that the limit, if the right hand limit and the left hand limit are different, it means that the limit at that point, which is the limit as x approaches 0 of 1 over x, this here does not exist. It doesn't exist. So because this does not exist, it does not exist. But in the first one, we found that the limit, so for the first one, when we used y equal to 0, we found that the limit is 0. But here we are finding that the limit does not exist. So because the limit does not exist, it means that I've taken a different path and it has given me something that is different from the other one. Hence, the limit of this function of that there a function, of course, does not what does not exist. Okay, so this is how we prove, or this is how we show that the limit does not exist. If you are new, remember to hit the subscribe button, and I'm gonna see you in the next one.